Now, let's talk about instantaneous velocity. Previous video was on average velocity, but now we move on to instantaneous velocity. So the discussion in this video here will be quite similar to our discussion in instantaneous speed. Okay, just a little bit of more direction involved because velocity is a vector quantity, whereas speed is a scalar quantity. Okay, so at a specific time t, which we use the same specific moment, time t over here, if you want to determine the instantaneous velocity, mathematically, this is mathematically, what we do is we take the average velocity, the equation for average velocity, then we limit the time duration towards 0. So what we do here is we introduce a limit notation into the equation for average velocity, thus changing it into instantaneous velocity. Again, limit time duration towards 0 means because previously average velocity, we were talking about a specific time duration from t0 to t3, let's say. But now when we move on to instantaneous velocity, we only focus on a specific moment, a specific instant. Thus, a specific instant is a very, very short time window, so we have to limit our time to a specific small window of time. Okay, and that's where the limit notation comes in. So if we change it into symbols, displacement here can be represented as the change of position. So delta x. Delta means change, x means position. Change of position divided by time duration. And if we move on further, we know that since we are limiting delta t to 0, we are making it an infinitesimally small time duration. Okay, and we learned back from secondary school differentiation, if we use triangle, triangle means a finite change. A finite change can be a big change, can be a small change, can be a very, very small change, nothing specific. It just need to be a definite change. But now we are we are approaching 0, we are shrinking the time duration to be a very, very small time duration. That's where we change our delta sign to become a d, because d means an infinitesimally small change. Okay, so this is mathematics. You change from delta to d, and of course above that there's delta, you change it to d as well. Okay, so now we know that vector velocity, vector v, is equals to dx over dt. The infinitesimally small change in position divided by infinitesimally small change in time. Okay, and again, since this is vector, if you want to do calculation, what we do is we resolve in the x component, and you get vx equals to dx over dt. Well, vx is the x component of velocity, x is the x component of the position. Okay, so let's graphically try to express what we're trying to say here. When we talk about instantaneous velocity, what we do is we focus on the specific moment that we are interested in this case the time t, this specific moment here, which is at time equals to a certain second, a specific moment. So what we do here is we check for that infinitesimally small duration, what is the change in position that happens to the object, in this case the person. So as you can see here, initially the person's head is over here, but within that infinitesimally small duration, the person undergo a small change of position towards this final position here, which is represented by the black half circle over here. So we can say that this change of position, we can represent it as dx. And of course, since it's a infinitesimally small time duration, or it's a very short time window, you are not able to travel very complicated path. Okay, you probably just move by this much only, this much only. So in that case, right, you should always expect that this is a very small change in position, and the motion from this initial position to the final position, you should always assume it to be a straight line motion. You won't expect any curvy line to reach the final position, because it's a very, very short time. You just move straight into it. Okay, you move straight from the initial position to the final position, and therefore you know that the direction of velocity, the direction of instantaneous velocity, will be the same as the direction of this little arrow over here. And because I say that you cannot move complicated path, you can only move this way, you should expect that the direction of instantaneous velocity to be exactly the same as the path of motion. If I'm moving in this direction, I should expect my direction of instantaneous velocity to be pointing in the same direction as where am I moving. Okay, because it's a very short time window, you won't be able to change your direction within that small time window. You cannot change change your path. Okay, so you should expect the direction of velocity, instantaneous velocity, to be the same as the direction of motion at that particular moment. If it's moving to the left, then the direction of instantaneous velocity is to the left. Okay, so now we know that. Again, similar to instantaneous speed, we cannot determine the instantaneous velocity at any particular moments over here because we don't exactly know how the person moves, whether it runs sprint very fast or sprint very slow. It's not within what we know. And over here, whether it's jogging, sprinting, we don't really know. So if we don't really know exactly how it moves, we can't determine the instantaneous velocity. Okay, this is a bit different from average velocity. Average velocity, you don't need to care how it moves exactly. You need to know earlier, where is it? Finally, where is it? That is average velocity. But instantaneous velocity, because it only focuses on a specific moment of time, you need to know exactly what happened within that specific moment of time. That's the difference between instantaneous and average. Average, you know the start and end. You don't need to know everything in between. But it can be valid for a time duration. But instantaneous velocity, you focus on a specific moment, and because you focus on such a small moment, you need to know for sure what is happening within that exact moment. Okay, so that's the difference between average and instantaneous, and the only instantaneous velocity that we know is at this specific moment t1, where instantaneous velocity at this instant is 0. Because it is making a U-turn, expect a little stop before changing direction.